In the previous section, we managed to push this to our phone. Now it's time to actually dive into what makes the game an actual game. So we're going to be looking at making gameplay prefabs today, and those gameplay prefab will be basically element of gameplay that will make your game either fun, hard, complicated, headache level, or just in general not fun. It really depends. If you're good at making those gameplay prefab, it's going to show and um, it's going to make your game quite more fun, depending on your skill at making those. And I just realized that I've been using the wrong material for that while. Actually, there's no problem in having these two material, but I remember that we're using the Atlas texture one that we've created instead of just the one called Atlas. And I'd like to start using this one here because it's on the top level and it's not related to the models down here. So here's what I'll do. I'll just make sure I copy the curvature value in this one, and I'll apply it here at the top, which means this one will now have the 0.5 curvature as well. So that being said, we have this block, and what is important to do is the following. We are going to create ourselves a new folder called prefab, and I'll create another folder within that called element. So those are going to be element of prefab. So you could call it building blocks. Once you drag the block like so you click, hold, drag the block inside of element, make sure you save the original prefab. Now it doesn't end here. So once we have the element, the block prefab, we are going to double click inside of it and it's going to open inside of the nested prefab editor. And this is where we're actually going to have to do a little bit of work. So depending on this object, depending on the shape of this object, we are going to have to create a collider. So on the same objects on the block itself, I will be creating a box collider. And I see that it actually fits the object quite well. Maybe this is a little bit too high. What I can do is I can edit the collider and just bring that down just a tiny bit like so. That's a little bit too much though. There we go. So it matches the collider better. We will need to have a collider on this object for the sole purpose that it needs to, our player needs to stand on it. And we could maybe squeeze it a little bit so it's really good on the sides. There we go. And we should be golden now. So saving this, I'm gonna head back and we have our first gameplay prefab. So I'm gonna keep going. For the next one is the blocker. I'll go ahead and I'll drag and drop my material on top of it. So this atlas, drag and drop in the element, open, and this one is a little bit more tricky. So we're gonna need more than one collider most likely. So I do recommend you use a box collider still. It's the second cheapest collider, the first one being the sphere collider. So if you were to use like the mesh collider on this, you're gonna be computing a lot of information that you don't necessarily need. So I do suggest you use this one. And do remember that for this one, for this very specific object, you'll want to make it collide with these pole at the same time. So here's what I'll do. I have one box collider that looks good. I'll use the second one, and then with the second one, collapse it on this side. Oops, like so. And we'll go for a third box collider actually. So here it is. It's actually more efficient to do this than having a mesh collider. So having three box collider like this is less expensive than having a non-convex shape as a collider. And we are good to go. That being said, now once we go outside of the prefab itself, you're going to see that the colliders are here. Okay, amazing. Next up, coin, diamond, fish. I'll skip all of them. The only three that I'll do for the rest of this video is going to be the following. So the ramp ice, ramp wood, and also the rock. I'll start with the ice. I'll apply a material to everything first. I will drag and drop all of these at the same time. Oh, I can't. So here we'll do it one by one. And we're going to head inside of them by double clicking directly inside of the project folder. I double click on ramp ice, and then from that point on, I can go at the box collider. And then you'll realize that this one is going to need a sort of rotation. This is not going to cut it if we just leave it that way. But at the same time, there is no way to actually rotate a collider. So the only option we have at this point is either have a mesh collider, which is going to create a very, very defined, as we've mentioned, a very, very defined object. So if we put it on the wireframe, it's hard to tell, but it's going to be a lot of polygon here that's going to be taken care. And it's not a convex shape as well, so it's going to be very expensive. That's one option. It's not the option that I like. So the one that I would like in this case is instead of having just this ramp ice, we have this as the graphic. So this is how it looks. And beneath it, we have an empty game object that is actually a box collider. Now that box collider can be rotated at your need. So here it is. I have this box collider. I can now say move it here, for example, extend it like so. I'll make sure to get the proper size. And now I'll move its transform right where it should be. So something like that. Now, the cool thing about our game is that we don't really have to care what's beyond this point because we only go in one direction. So after this point, we can have this without causing any trouble to our game. And just to make sure that it actually goes within the floor, I'll just extend this a little bit more. And now we happen to have a collider for this object as well. And the cool thing as well is if we feel like it's not right, the angle is too steep. Since it is a prefab, we'll just have to change it here, and it's going to change it for the rest of our game before we go any further and create a whole bunch of gameplay prefabs. So to save a little bit of time, I'll copy this object that I've created, go under ramp hood, and I'll paste it right beneath. There is an offset that we have to figure out though, so I'll make sure to reset that for both of them. Now I would like to move this object towards the left, but the gizmo goes in this direction. What I can do is I can change the pivot point from local to global, and that lets me move it smoothly like that. Okay, let's go back to heights. I just want to make sure that I don't have this offset. And here we go. Perfect. And finally, we have the rock. Now, the rock is a tad too big. Like the player can't jump that. That's very, very high. So I'll just scale it down to say 0.3 on all axes, and I'll put a box collider on it, which is going to cover this, and it's good enough. Might want to make it a little bit smaller so it's easier for the player to jump over it, like so. And here we go. We now have a bunch of gameplay prefabs. Actually, sorry, gameplay elements. In the next one, we will go ahead and create gameplay prefabs. So previously, we created ourselves 5 different gameplay elements, and here they are. So that's the block, the blocker, the ramp ice, and the ramp wood, plus the rock. Now, what we'll be doing today is we are going to actually create gameplay prefab. And under the prefab folder, I'll create myself another folder called gameplay. And these are going to be chunks. Now, these chunks are chunks that will spawn. For example, we'll spawn one right here, one right there, and so on. So these will continue being spawned over time. And being good at making these is going to make a big difference on whether your game is fun or not. So let's go ahead, and to get started, I will right-click and create myself a new game object, empty game object, and I'll call it chunk. I'll place it at the origin of the world, and then I'll move it over to my gameplay prefab folder. And now we have an empty game object just sitting here. And it's going to be very important that at this point on, whenever we do changes, we are going to enter the nested prefab editor. So I'll go ahead and actually just move this a tiny bit towards the right. So it's at 5 exactly, or at the end of this road. And I'm going to enter the prefab. So either click on this arrow, open, or double click on chunk. Now, once we're in here, we can start laying down the actual prefab. And for the moment, since we don't have any floor, I will go ahead and I'll create myself a 3D plane. It's not always going to remain that way, but for the moment, that will do the job. So one thing I'd like to do is before we go and we create our gameplay prefab is just to move this over 5 meters in the front. So our prefab actually starts right here, but I want to have an offset a little bit. So I want to make sure that I don't go on this side. When we spawn this, it doesn't overlap with the previous piece. You'll see the difference if you are under pivot. So if you have the pivot option at the top left here, when you select chunk, you'll see the beginning of the chunk and then you have the plane. And what I'll also do is we'll have the option to create different type of length for our plane. So you can have that uses, for example, here 20 meters. And to do that, I just duplicated my floor and I just kept moving forward with it. Now it's time to start laying down the gameplay element, and make sure you don't do the same mistake I've just did a couple of seconds ago. You didn't see it, I'm going to cut it in the video, but I've started importing models from the model folder, and that's not what we want. So we created ourselves gameplay elements, and we should be using the one we have right here in this folder. So I'm going to go ahead and just reproduce what I had a couple of seconds ago. For the moment, you might think that the curvature really doesn't help just to see where you're placing things. So you might remove it for the time being. And I am going to go ahead and just put it, say, right there. I'll create another block, put it 3 meters apart in terms of the x-axis. And that's because our lanes are every 3 meters. So there's going to be a lane here, there, and there as well. Something else we could do is say, for example, put this right at the front, so we have a way to get on top of this object, and maybe the player can jump here and collect fishes later if we actually can put some on there. And then let's do a blocker on the right hand side, so he doesn't get to just walk for free in this lane. He has to do at least one action. Okay, so this could be one gameplay prefab. This could be one chunk. And once we have this, I suggest we go back to the scene, have a look. Okay, so it looks something like that. When our player moves forward, he is going to have to either get on top of this, that, or that. And that right here is one chunk. And now, if you want to have a game that looks very different and that is a little bit more fun, then you want to randomize these quite a bit. So you want to create a different version of them. And then once we spawn them, we will have a randomized version. So to keep on going, I'll go ahead and I'll create myself a chunk 2, for example. We can rename this one to chunk 1. And for chunk 2, I'll just move it at the origin, 5 meters apart. And I'll actually just go here and I'll start laying down another chunk. So drag and drop. Let's go in here. I'll put some floor down to make sure I save a little bit of time. I can go back in my first chunk, take the 2 planes which act as the floor, put them here. And I want you to remember that that's not always going to be the case. So we're going to have our own floor later on. But for the moment, just so we can see where we're placing our elements, then I'm placing this down here. That's the sole purpose. So eventually these will go. And that being said, we can start laying down a couple of elements in here. So maybe a rock here and a rock there. Maybe like so. So at the end of the wooden ramp, you would still have to jump, else you're going to fall on the rock. So that could be something. And I've just realized that I have something missing in here. There's another element that I didn't put in the right place, but say around here, this log was a gameplay element. It was actually crafted to be very, very similar to the block. So I'm actually going to take this, the log. I'll go outside, take the log, make sure it has the right shader on it, and I'll save this in my gameplay elements folder, like so. We can then enter it. put it at the origin. And I'm actually seeing this is on the wrong side. We could flip it over if we want to, like so. Add a box collider to it and just resize this so it's a little bit more convenient. There we go. This will give us a little bit of different look for our blocks at least, so that's going to be good. Okay, so now we have a new block we can use. And I'm seeing here that the chunk is actually apart. It's not at the right place. You can see here that the pivot point is right here, but once we go inside, it has displacement of 5 meters exactly. So let me go back inside of here and move this over 5 meters. So our chunk starts right here, and then the rest, oh, I missed it. And the rest starts on top. If we go back to the scene, you'll see that it is now fixed. All right, so I'll go back in the chunk and add a little bit of detail with, for example, the log that we integrated last time. Maybe I'll want to have it here. And another one here, which will force the player in the middle lane. So this chunk right here seems to have an issue with its pivot point. So as you can tell, the pivot point is right in the center, and then you have 1 full meter here and a little bit more, but not on the right-hand side. So the collider is not really adjusted with this, and it's just overall a little bit too big. So what we can do is open up that log and first mess around with the collider a bit so it's a little bit more sharp. It's a little bit more, it makes a little bit more sense. And just like this, we replace the collider, but visually, I still think this is off. So what we can do when we have assets like this we want to keep in our game is we can split the collider part and the visual part. Actually, no, sorry. We can split the visual part all together. So I can actually decide to, for example, grab this log, put it under the log, and now I'll try to turn this one into a empty game object. So put that at the origin of the world. That's fine. I don't want to have the mesh collider. I don't want to have the mesh renderer. I don't want to have anything on there. It's just a placeholder, really. So now I can start fixing this log by just swapping it over, putting it back to where it should be, and just visually making sure that it makes sense, really. So roughly around here, I believe would make a little bit more sense. And we keep all the information we had earlier. So, we still have a material on it. We still have the mesh renderer. We still have the collider. But the one that drives everything is this empty game object. The one that drives its position is this empty game object. And if we are to go back in the scene, we can tell it's a tad better, but not quite yet. So we can go back, move the log inside of it roughly like that. Go back to the scene, and you'll see that now I have a little bit too much on the other side. So that should do it. Yep, we now have proper spacing in between them. And that could be our second chunk already. So with that in mind, we are not going to stop here, but I do encourage you make a lot of these, and do understand as well that you can make them as long as you want. So we've made them 20 meters right now, but in the next video, we'll do a script that we will actually decide what is the length of our prefab on a chunk basis. So you can have one that's 30, you can have one that's 10, you can have one that's 5. Like we don't actually need to, you don't need to respect the 20-meter limit that we've set here. All right, with that said, in the next video, we will finally start tackling code. So we will create our first script in the next one. So I'll see you there. For a good amount of time, we were just placing assets around. We were just making sure we had some visual to look at. But then finally, we can start looking into writing some code. And I don't want to do a big introduction to coding. If you are here, you most likely know how to do C# code, but I'll go very slowly initially. So we have these pieces here, these chunks, and these chunk will act as its own object, you could say. We would need to store information of these chunks, such as how large are they? In the end, we are going to have some kind of engine that is going to run over time and say, hey, the player is 20 meters in front of the initial spawning position. Then we would want to be spawning something that is say 30 meters. That's cool. Okay, then the next piece is going to be at 50 meters. So these chunk, we're going to be putting them as object. So a chunk is going to be an object. It is going to contain, for example, it's going to contain a certain length. So we know, hey, this chunk is exactly 20 meters. So when our world spawner actually goes and spawn these objects, then it is going to know that it's 20 meters, and the next piece can be 20 meters after that, and this kind of information. So without further ado, I'm actually going to create a folder called world generation. And I'll create a new C# script called chunk. Just like that, we're going to have our first script called chunk.cs, and I will double click on it to open it in Visual Studio. If you don't use Visual Studio, that's totally fine. If you use Visual Studio Code, that's also cool. If you would like to change which editor pops up when you double click, you can always go under Edit External Tools. Project setting. It's not project setting. Okay, so Edit, Preferences, External Tool, and you can change it right here. So on my computer right now, I have Studio 19 and Studio Code. So I actually like using the Studio 19 because I'm on Windows. If you're on Mac, you can't do that. So I would recommend that you use 19. Okay, so our first script is going to be quite simple. I'm going to start by removing the two using statement at the beginning here. We're not going to be using system collection or just system itself. Everything we're going to do is quite simple. And also you're going to see me during the whole course that I like to just delete everything in the script and just start fresh. But most of the time I just rewrite the start and the update anyway. So now you're aware. One thing that we'll need to know, and I've mentioned, is we're going to need to know the length of this chunk. So we could call it chunk length. And I store it inside of a float. The first thing I'll go ahead and I'll create is a public float, which is going to be the length of this prefab. We can call it chunk length, like so. Now, just by having this object right here, this one is public. It is going to show up in the inspector. We could technically go here and do a serialized field private float. It will still show up in the inspector. You can still modify it. But in the future, I would like to be able to access this from my world editor, my world spawner, actually. And then this object is going to have two functions. One is going to be for showing the chunk, so initiating the chunk, just showing, okay, putting it on active. And one is going to be for hiding, because we're going to be spawning these. But then once we run past them, once it's like a chunk that we already crossed, we are not going to delete them. In fact, we are going to just disable them and hide them for a moment until we need them again. This is a optimization technique called pooling, and we will implement that here. So to do so, we could do show chunk and another one called hide chunk. I made sure to return void right now, but you know what? We could actually return ourselves. We might want to use this in the other script using this. So every time I will do return this. Okay, now for show chunk, it's going to be fairly simple. All we want to do is take the game object of this basically this script, and do a set active false. Now it's going to be fairly simple here. All we really have to do is take the game object and set active to true. Same thing down here, but of course, instead of setting active to true, we do false. And that's it. That's actually it. And you'll see this more and more with our script going further. We want to keep things very simple, and it's a way we do code here that is much appreciated from all the YouTube videos that I've made in the past. People seems to really appreciate how easy and how clean we keep them, and it's what we're going to be doing going forward to the best of my ability, at least. So we have a simple object that has two functions and a simple float. With that in mind, we can now go ahead, go on our chunk, and drag and drop this component because it inherits from a mono behavior, and just put it here. Now, we could say 20, because that's the length of this chunk, and the other one is also 20. So what we just did right here is that we've created these two chunks and we've added the script to them and we've inputted the chunk length manually. Something we might want to visit in the future, and if we do, which we will most likely will, is to actually calculate the length of this without having to write it manually. So maybe just calculate the length, see with all the objects within this one if they're out of boundaries, and then maybe floor that to the near S.5. So if we have, say, an object over here, it's going to detect that it goes that far, and then the length can be put on 30 in this case. We might do that, and if we are to do that, I'll put that on a optional video in here. But for the moment, this will do the job. And let's make sure we actually save these prefabs. So on these, override, make sure they are saved, and we're then ready to move on to the next phase. In this video, we are going to actually start creating them in front of the start location. So I'll be just moving these two chunks. Actually, what we could do is completely delete them because now they're going to be instantiated directly from script. And we are going to start laying down that script. I did mention that we're trying to keep everything simple, but some of the things are going to be a little bit more complicated. So this new script that I've just created, worldgeneration.cs, is going to contain a total of 6 functions. It's not very complicated, but still, it's a big step up from the previous one, which only had 2. So I'm cleaning it up as I usually do, and I will lay down a private void start. I will also lay down a private void update, followed by a private void scan position, and I'll explain what this one does in a second. Another one called spawn new chunk. Another one called delete chunk, or delete last chunk. And finally, a big global function is going to be public for resetting the whole thing when we die or when we want to play again. Okay, so one by one with these two. These two, you probably know what they do already. So that's something you've set only once at the beginning of your game. It's a start. The update is going to be constantly being ran every single frame. Scan position is going to be looking for the camera position, and it's going to keep asking the camera, are we far enough to the point where I need to spawn a new chunk? So in the update, we're always going to be calling scan position like so, unless we enter some sort of the game is paused or the game is not currently active. So this one we can already fill in and we can already wrap up the update. It's only there so we can try and scan the position. Next up, we got spawn new chunk. So if we are beyond a certain point, so if the scan position determines that we are to some extent far enough from the last chunk behind us and we need to spawn a new one so we don't see the empty in front of us, then we're going to spawn it. And delete will not technically delete it, but it's going to take the first chunk, the one we just passed, and make sure to disable it. So it's going to call its hide function right here. Okay. Are we ready to get started? I believe we are. So going at the very top of our script, we are going to start laying down fields that we'll use. The first one is going to be called chunk spawn z. Now this object, this float will actually contain where is the last spawn chunk, so we can actually spawn it, spawn the next one after that. So it's going to be a matter of keeping track of where we are generating stuff in the world right now, knowing that we start at 0. Next up, we need to keep a list of all the actual active chunks. That is so the chunk we spawn and then we despawn, we keep them all in the list. And if we need to spawn another one of the similar chunk, then we're going to go ahead and pick one from the active list. So those are all spawned. They might be inactive during the gameplay, but they are still within the list. And at one point, it won't be spawning chunks anymore, and we won't have any spike in the performances. This next one, I'll actually put it under the gameplay section. And it's going to be a private queue of type chunk. So the type we just created in the previous video. And we call it active chunks. Now, this one is going to contain all the ones that are currently active. So So it is a queue. So if we spawn index 1, 2, 3, we can then go back at the beginning and say, hey, pop the first one, and we're going to put something back on top. So it's a queue, so we can take out the first one that got spawned when we try to despawn these. But then on top of that, we are going to keep a list of chunk again that is just the pool. So the chunk pool. Because once we take them out, chances are we want to keep them in memory somewhere. Because we don't despawn them, we don't destroy them, we just set active to false so we can reuse them in the future and create that pool behavior. That being said, we pretty much have all these fields here that we can't configure, so all the private field. And then just beneath that, I will create a section for configurable field. And now for these fields, while they will be private, I will make sure I can serialize field them at the beginning so we can modify them within the inspector. The first one being first chunk spawn position. So depending on how much space you took while you were making that little scene around our player, so depending on how much space you took here, you can modify the first spawn chunk position to just spawn a little bit further. Okay, quite simple. Next one is going to be a private int, int chunk on screen. So how many chunk are we going to have on the screen at the same time? 3 is a good number if we want to test out. At the end of the day, we might want to have 5. If you see performance issue, we can drop that down to 4 or 3. But let's actually start with a big number. We can modify that directly in the inspector, by the way. So that's not an issue. But the reason I want to start with a big number is so we can have a nice amount of spawn object at the beginning. We can visualize it fully, especially with the shader. So next up, we have a float for despawn distance. That will stand for how far away do we have to go after a chunk before we despawn it. So I say roughly 5 meters will do. Since it's a float, let's just go ahead and add the F next to it. And finally, the last two we will be using are a little bit outside of this section here, but they are a list of game object for the list of prefabs, so chunk prefabs, which will contain the full list of everything we can spawn, and then private transform, and that's going to be the camera transform. So these two we will set manually, and we technically wouldn't have to change them at all unless we add more chunk in the future, which we will. We only have 2 right now. So we're going to be playing around with these 5. And in fact, I bet it's time to take a small look inside of the editor, see if everything compiles right now. It seems like it does, so we don't seem to have any issues compiling this. And yep, let's go back. It's good sometimes to just go ahead and check if everything compiles, if you don't have any error, any syntax error. All right, so with all of these and without any syntax error, we're now ready to start tackling the body of these. And the start is going to be fairly simple. We have 2 things to do here, and we'll note them at the top. Check if we have an empty chunk prefab list. If we do, then we can't span anything, and that's going to be a problem. So we're just going to log an error. And finally, try to assign the camera if it's not already assigned. So camera transform here. That's the 2 things we have to do. And let's actually go ahead and tackle them right now. Those are fairly simple function. So chunk prefab, if the count of that is equal to 0, then we have a problem, and we can just safely say that it's not going to work out. So we could throw an exception, but I'll just stick with doing a log error and say no chunk prefab found on the world generator. Please assign some chunks. And then I'll return. I don't need to go any further than that. At this point, it just means we call it a designer error. Next up, we're going to look on the camera. So if camera transform does not exist, so if it doesn't exist, you put the exclamation mark in front of it. So if it does not exist, if it's equal to null, because we probably didn't set it, then let's go ahead and do camera transform is now going to be equal, to camera.main.transform. If that works out, that's perfect. But let's just write it down here, not as a log error, but just as a normal log.
we've assigned camera transform automatically to the camera.main. You might want to change this if you have multiple camera. So that is what it is going to do at the beginning. Okay, the sole purpose of our start is now completed. So is the update. We have 4 more functions to go and they're quite big. So please tag along. We can get through this. The hardest one is actually the next one. This is the one that is a little bit hardly complex because it contains a little bit of math. All right, now for the scan position, functionality wise, it's very simple. If our camera goes beyond a certain point, then we go ahead and we spawn a new chunk. So we do new chunk, and we also delete the previous one. But that's only if only we go beyond a certain point. So if we are far enough, then go ahead and spawn a new chunk and delete the other one. I'm just gonna go ahead and remove this and try to code a little bit cleaner. There it is. So our condition right here is going to be all about trying to find whether or not the camera is far enough. And for this, I'll declare a small float. I'll call it camera z. And it's going to be equal to the camera transform position.z. And you're going to realize here I just did a mistake. We can simply do this. Okay, so with the camera transform z, we're going to need to know a little bit more information. Now we're going to need more information than just where the camera is. We're also going to need information on where is the last chunk that has been spawned and how long is it. So this is where we're going to be using the chunk object, the one we've created. And I'll call this last chunk active chunks.peak. So peak basically goes at the very last object in the queue, and peak simply returns. So instead of doing something such as it's the index active chunks.length -1 or count -1, it does that through .peak. In fact, you probably can have a description of it if we just over this. Nope. Okay, so just trust my word here. It takes the last element in the queue. With this in mind, we can now start looking into making our function. So we're going to need to know, hey, are we beyond the chunk? If we are beyond the chunk, are we beyond its length? And if so, are we beyond its despawn distance as well? So on the left side is going to be camera z. If that number is bigger or equal, then last chunk dot transform dot position dot z. So right here, we are now on top of where the chunk is going to be spawned. We don't have its distance, however, so we're going to do last chunk dot prefab length. Oh, sorry, chunk length. And then if we just leave it at this, then as soon as we leave the chunk, it's going to despawn immediately. And we want to give it a small buffer because sometimes you might see it despawn if you have an object that is very tall or was in front of the camera. So we can do despawn distance, just like so. And that's it. So every frame, we're going to be looking at spawning a new chunk and deleting the last chunk in case we go beyond a certain point. All right, so we can wrap up this one, and we are now at the most complicated one, the most complicated function for this whole script. And I'm going to try and break it apart. We are going to first get a random index by looking into the list of prefab we have available to us. We'll get a random one from the list. So first step is going to be get a random index for which prefab to spawn. That's the first step. Followed by, does it already exist within our active chunk? Within our pool, not the active chunk, within our pool. If it does, reuse it. And if it doesn't, then go ahead and just place the object and show it. It's pretty much as easy as that, but it's still the most complicated function we have here. So the first step is going to be to grab a random index. We can do int random index and do random.range, which will pull a number in between a minimum and maximum. In our case, we want something in between 0 and the amount of prefab inside of the chunk prefab. So a dot count over here. Okay, we have our random index, fairly simple. So to keep things a little bit easier and a little bit more clean, I suggest we actually do that within a different video. So what we'll do is, for the moment, I will simply declare a chunk that we'll call just chunk, and we'll put that to null. Just do note that we're going to come back to this part in the next video, just so we can look within the list, see if we have already something that exists and that is not active. But for the moment, we're just going to assume that we did not find any of that. So one additional step that I forgot to mention here is, if it does not exist within our pool, if we were not able to find something that is within our pool and that is not active, then we'll need to create it. And that's what we'll be doing right here. So create a chunk if we were not able to find one. To reuse. Okay. That being said, we are now going to start writing this code. It's going to be fairly simple. So if we found nothing, so if chunk is equal to null, we could also say if not chunk, then we have to use the game object, the mono behavior function called instantiate. So instantiate like so. We'll do chunk prefab, which is our list of prefab at the index random index. And we actually want to set a parent. Now, the whole world should be contained within the world generation object. In my head, I think that's the best case scenario. We don't want to leave that on the scene level because I think that's going to be very messy. So instead, I'll put it under transform. Do note that when you send a second parameter here, it asks for a transform and they name it parent. So this is going to be put under the active objects, the active object which has the world generation script on it. Okay, now that we've created it, it's time to actually grab the chunk component on it. So I'll say chunk is equal to geo get component type of chunk. And now we have a reference to this, and we won't be losing it because it's going to be stored within the pool. So right after that, place the object and then show it. We're going to do chunk game object transform position. Can we just do dot transform? Yeah, so position is equal to a new vector tree, 0 in x, 0 in y, but then we want to put the chunk spawn z because we spawn it after everything else. And then at this point, we can say, hey, the chunk spawn z, we're going to prepare you for the next object. So when the next object comes, you're going to be spawned at whatever you are now, plus the length, the chunk length of this current chunk. So if we're on 10 and this chunk is 20, this is going to be set on 30. So next time we spawn something, it goes right at a good place. And also, let's store the value to reuse in our pool. So we do that by just saying active chunks, so the ones that are active, enqueue chunk. And also, finally, chunk show chunk, which is our function, our custom function we have inside chunk.cs. So let's quickly go through it really fast because that's the most complex function for today. The first thing we do is we grab a random index in between 0 and how many prefab we have available to us. We look if there's one available in our pool that matches our criteria. So it's a disabled object that has the same index as us. If there is not, we create that chunk, we grab its chunk component, and then we place it in the world. We make sure to increment our chunk spawn z, and then we put it inside of our queue, so the active chunk, so we know which one are active and which one are not. And finally, we call the show chunk. Technically, since we just instantiated, then we don't necessarily need to do this because the default of an object that is instantiated is going to be put on, it's going to be enabled here. That's all we do. But in the future, once we start hiding chunks, then it's not going to be that simple. So we need to make sure that we actually call it. Okay. All right, the last two functions are quite fast to do, and I know this is getting tiring because it's a very long video, but I'll do it fairly quickly. I'll first grab a reference of a chunk for the active chunk.dequeue. Now, what this does is it takes the first one we've put, so the oldest chunk, and it removes it from the list. But at the same time as it removes it, it also gives you a reference. So you have a reference to the last one that just got removed from the list. Once we have that reference, we can call our neat function we've made called hype chunk, and then we can add it to our pool. So chunk pool dot add this one, and that's all we do. So make sure you remove it from the list that is active, hide it, and add it to the pool. As simple as that. So when we reset the world, we want to reset the chunk spawn Z, but we also want to delete all the chunks and just reformat a new world after that. So to explain in blunter terms, we have to delete everything from the list, reset our chunk spawn Z, and then spawn again maybe 3 to 5 object, depending on how many we have under our chunk on screen object, value. So it's very simple. Chunk spawn Z is going to be equal to the first chunk spawn position. That's good. And then followed by 2 for loop. So I'll just have them created here for me. Instead of saying is equal to 0, I'll say active chunks.count. We're going to iterate on this as long as I is not equal to 0, and we'll do I minus minus. So we're going backward. We're iterating through the amount of active chunks backward. I think a for each would have done it, but since we're disabling objects and we're removing from the queue, chances are we might get a IEnumerator error. So all we have to do is delete last chunk in this case. And since we only have one function in this, we don't need to put the brackets around it. That being said, once this is completed, we're going to spawn new chunks again. So again, same thing, int I is equal to 0, as long as it's smaller than the amount of chunks on screen. So if we say 5, then it's going to be 5. We are going to spawn new ones, so new chunks, like so. And we've done it. We've made the world generation script just like that. We're going to have to come back in the future and tweak this a little bit more. For example, down here for the pooling. And we'll have to come back to spawn additional type of chunks once we're done. So this one we're not done with completely, but we've done the biggest part, and it's going to work already. So if we're going to go back, it's time now to implement this, and I believe I'll do this in the next video so we're not confused. So if you see any syntax error, if your code doesn't compile right now, I do suggest that you go ahead and you grab the script from the resources. But until then, I'll see you on the next video where we will actually implement this. Cheers. All right, so previously we were able to add the world generation script. We actually created it from scratch. Now, what we're going to be doing today is we are going to be implementing it in the game. And if you have any issues with this script, if you had any problem, just make sure you look at the previous video resources, because the script is going to be in there. You can download it and you can copy, paste it if you wish. Else, this is the whole thing we did. I'm not going to go through because it was well covered in the previous one. So it is now time to implement this object. And to do so, I will right click, create myself a new object, empty game object that I'll call world generation. And if you remember, when we were to spawn new chunks, we were actually going to do it under transform, which means whatever object that the script was under. So as I drag and drop the world generation script on top of this, we will now know that this object in the future will contain all the chunks spawn in that direction, so positive Z. And if you remember, we had a little bit of tweaking to do. We gave ourselves a couple of things. So for example, chunk on screen meant that we had to spawn 5 chunks. Despawn distance meant that we had to wait 5 meta before we would despawn the previous object. And the one that is very important right now is the chunk prefab. We have 2 of those at the moment, and they are under, where are they under actually? Artwork? No, prefabs, here they are. And chunk 1 and chunk 2. So I'll drag and drop them here. Camera transform, I'll manually put it in there, but do note that if we're not putting in there, the script would find one under camera.main. And I'm going to hit play Just see what happens. And unfortunately, it says queue is empty. So we do have some issue. So what actually happens here is the queue is empty because it's trying to do something that does not work right now. So knowing that there is only two entry point right now to our game because we're not referencing this from anywhere else, we only have the start and the update. So looking at start, nothing really happens here that could be causing any problems. So most likely update is calling scan position, and it might be looking to actually spawn a chunk right away. Now, to address this problem, I will go up here and do a private void awake. The reason this is, and that we didn't put it in the previous one, is because this is eventually going to remove. I will want to be able to control my world generation script a little bit further down the line from another script, one that would control the whole flow of the game. But at the moment, there's really nothing that controls more than this. So we're starting with the world generation, we're starting with the visual, and I will be putting a small note in here, and I'll call it to delete. And I like to do a double dollar sign because at the end of the project, if there is thing that I forget, if there's function that I forget, I always do a find all on the double dollar sign and I look for these in. Here it is. So this region here will be deleted eventually. But do note that in a awake call, not the start, so I believe you could put it in the start. Yeah, you could technically put it in the start. But just to separate them right now, I'll do a reset world. And do note that in the reset world, we actually spawn some new chunks. So we spawn whatever amount that we want to have on the screen. So we spawn them here. Technically, this is going to fill the queue and we won't run into any problem. So that being said, it is now time to press the shiny play button. And it's a mess. It's a total mess. But as you can see, we spawned a total of 5 chunks. We can see them here. 1, 2, 3, 4, 5. They are spawned at a weird angle. I don't know why I put -10, but it was definitely not -10. It was 10. And we see that there is a variation. So we have the first chunk, and then we also have the second one here as well. Now, obviously, to create some more randomized effect, um, we're going to need more chunks in the future, but I believe as we work on this, this is enough. So that being said, let's go ahead and tweak this a little bit more. The first spawn position for chunk should be 10 and not -10. I'll play this again, see what it does. Okay, actually it should be 5. And there we go. So that already looks a little bit better. Now, the second thing that is a problem to us is the fact that these chunk they actually use the old way of rendering. So they just use a normal albedo and it doesn't have any curvature. So if you guys remember, under the atlas here, under this material, while we were working on this, we actually set that back on 0 for the sole purpose that it was really hard to work with if it had the curve. It was really hard to place. So I'm going to go ahead and put that back on what it was. So for this case, it was 0, 0, 0, actually 0.005. And I've put it back right here. I could be putting it on the floor as well, but we did mention that this floor is eventually going to go away. But for the purpose of just looking at if it works or not, I'm going to go ahead and drag the snow shader on top of these plane, like so. So that's it for chunk 1. Now for chunk 2. These ones should already be updated. So yeah, that's updated, but not the floor. So I'll drag the snow material on top of that. And we can now go back, press play, and this is what we end up with. A lot of tweaking has to do with the lighting, so we have to switch the light direction. But as you see over here, the police is coming for us. No, I'm just kidding. As you see over here, as we move forward, we're having this type of behavior, and that is fairly cool. Now, something else that we want to test out, and I'll test it out right now, is I'll look in this direction while I'm in the play mode. Control Shift F while I select the camera, and now the camera is going to be right here with me. And I'm going to try and move this one only on the Z-axis. So global Z-axis, and as I move, I want to see another chunk being spawned. There we go. And it's happening. So it's a little bit hard to tell because I'm going in definitely in the wrong direction, not the wrong direction, but in a weird angle. Let's see if we can fix that. So as I move up like so, use the global instead. And yeah, so you can see here on this side, on the left hand side, that as I move forward, I keep spawning different chunks. Now, the problem is right here is that we keep creating new chunks. We're not reusing the one that we had in the past. As you can see, as we move forward, we are going to have a lot of those just being spawned. And the faster we go, we end up with a very, very big memory overhead, and that's not something we'd like to have. So obviously, we'll have to look into pulling as soon as possible because that's just too many objects. But I'm glad that the camera, even though I push it very far, does catch up and does eventually create these without any issue. And you're going to notice that maybe we want to look into, let's see where we are. Maybe we want to look into either upping the curvature so we really don't see this at the end, or maybe incrementing the amount of chunks we have on screen. So chunk on screen could be a little bit higher here in this case. If you like to put that higher right now, feel free to do so. So I put that on 7, and now it's spawning a total of 7 chunks. Okay, so I'm glad this one works. In the next video, we're going to be looking into pooling these objects so we don't create new one every time, and it's not a big memory overhead, as you can see here. So I'll see you in the next one. Okay, so previously we were able to create all of these chunks one by one, and they kept on spawning, as you can see, and they kept on being just being placed at the proper place. Now, the problem we had is that we were not reusing our old chunk. For example, here, chunk 1 or chunk 2, they are hidden, but they actually never come back. So we never turn them on again and place them a little bit further. So today we're going to be looking into optimizing this, and we'll do this in a very, very simple fashion. So if you remember, in our world generation script, we had to go over here in the spawn new chunk, and over here we said I will come back here for the sole purpose that I wanted to make them separate so you can see how simple pooling can be. Now we'll do it in a single line, but the pooling mechanic is actually includes this part where we spawn it, and also this part where we put them inside of a queue right here. Oh, and one more, when we go and we delete the chunk, we add them to the pool. So our pooling mechanic is basically these lines plus this one. And now we have to be looking into our list. So we have a list on the right-hand side over here. I'll press on play so we can see it. We have a list that is right now empty. And as we move the camera, as soon as we delete one of these, like roughly right now, this one becomes part of the chunk pool list. And we need to know, okay, so chunk number 2 or chunk 2 is in the list right now. We need to look for it, and then we need to activate it. So here is what we'll be doing. We are going to boot up our script, and over here, we will write chunk pool dot find. Now, this is part of link queue, but it's actually quite fun to use. So here's what we'll do. It's a little bit complicated. We'll call our chunk X, and then we'll do a delegate into our condition. So basically, if I am to explain this very simply, chunk pool is a list. And when I do a find, I can then declare this as an element of the list. And as soon as it finds one that will match whatever condition we put on the right here, it will return this one. So X in this case is an element, it's a chunk. So imagine we're doing a for loop, and this is the first time we do it. That's chunk pool at the index 0. If it doesn't match, we'll move on to chunk pool at the index 1. If it doesn't match, 2, 3, 4, and so on. So the condition is going to be the following. We're going to start by looking if the object is not active. So x.gameObject.active self. And I'll put the exclamation mark in front of it. So what this will do right here is it will grab any objects in our pool that is not active. Now, the problem with this, as I run this, you'll see first our behavior. We have a chunk that is disabled right now, and then we move on. As you can see, it re-enables that chunk. Then we move on again, it re-enables the other chunk. But what if we actually had the index one? It doesn't know that actually. It's just going to go through the list one by one and just replay the same thing. Definitely not something we want. So we need to add another condition to this. We can't just be happy with grabbing whatever one is not active. We actually have to know if it's the proper index we'd like, because we use a random index over here. So if we were meant to spawn the second index and we're just grabbing the first one, it doesn't really make any sense. So we'll need to add a AND operator here and an additional condition. Now, there is multiple way we could have went and did this. We could have stored the index within the chunk.cs. This is actually what I've done prior, but I realized that we can do it in a much more efficient manner. That is just to look up the name, really. So we're going to have different name for every chunk. We can just do it that way. We could do it with a hash of the prefab, but that's a little bit more complex, so I don't want to get into that. So here's what we'll do. X.name is should be equal to the random, actually the chunk prefab at the index, random index dot name. One problem that we have into this is that x.name is actually going to be chunk one, for example, and then parentheses clone. So if you guys remember, when we run this, we actually have the name clone next to it, which means as we are to actually go forward with this, you're going to see that we keep on creating and it's not reusing anything simply because we're never getting a match, because our prefab is called chunk1, but the name of this is called chunk1 clone. So we can just add that on top of this here. I'll just wrap this up like so. Plus, and that's something Unity do. I'm not too proud of it, but hey, clone, just like so. So I'm matching with the name actually, and I found this a little bit better than just keeping the index. It's not as efficient of just as just keeping the index in chunk, but it's very, very light because it doesn't happen every frame. It only happens when we go beyond a certain point, and it's much easier to work with, and it keeps our chunk.cs script cleaner. So now as we go through this, do we get any, oh, it doesn't work because I didn't put the capital letter, because it's a string match. It has to match exactly the same. So capital C on clone. And as I mentioned, a more efficient way to do this is just keeping the prefab index within chunk.cs and look for that. But I find that we're going to have to modify our chunk.cs, which is very simple right now. And I would not like to do that. And as you can see, we are spawning things back like so. And as we move into the future, so look at my z index over here, as we move into this direction, we are going to keep playing with what we already have and barely ever have to instantiate anything else, unless we get really unlucky and we get a couple of chunk one all in a row. We are going to be playing with the same, and you can see here in the camera preview, we keep getting prefabs. We're going to be playing with the same exact prefab the whole time. Even if our player makes it all the way to, say, that far, 24,000, you can see it computing right now. And it's eventually going to catch up. But yeah, it takes a bit of time to get there. I moved quite fast. Eventually, we made it, and the chunks, they're all right here. And that is how we do pooling. So even after a long time, we still have only this, and we're not spawning too many chunks. And that's it, guys. So in the next couple of episodes, we're going to go back through that flow, back in the world generation.cs, and we'll actually spawn things on the sides here. So it actually looks good on the side, and it's a little bit more different. So that being said, I'll see you guys in the next one.
In the previous episode, we looked into spawning all of these chunks in an efficient manner, so reusing them from pool. And today we are actually going to spawn some more chunks, but We are going to need to redo the whole process we've done, but we'll do it fairly quickly in one episode. And those chunks we will be spawning are for the left side and also the right hand side over here. They will act as collider. So we will add some collider to them on the right and left side, so the player can't leave this place. And also on top of that, they will do scenery. So the reason I wanted to split them from the middle lane, you could say, is just so we can have some diversity. So if you are to spawn, for example, this prefab, it's not always going to be the same scenic around it. So if there's an iceberg here, if there's a whale, it's not always going to be the same if this chunk spawns. So that being said, it is now time to start creating that. So I will start by just creating myself a new folder under the prefab folder, and I will call it scenery with a capital S. And then I'll create myself a empty game object that is going to be reset at the origin, and I'll just call it scene chunk 1. Now with that in mind, what we'll need to do, what is very important that we do, is that we create collider on the left and the right side. So I'll add a box collider. Let's see if we can move the center of it towards -5 in this case. Yep, so -5. Let's do a bigger size in Z. So we want to have 10 in Z and also in Y as well. So I'll just put something crazy like 50. And with that, we now have our first collider. Let's go ahead and create another one. And I'll just copy these value, paste them here. And instead of -5, I'll do 5. And now at this point, our scene chunk now contains these two collider. Okay, but that's not what we're here for, really. We are here to actually place some floor and place some element of scenery. And just like with the previous chunk, right now we don't have the moving floor, but we can still create a plane for the moment that we will use for this purpose. So I'm going to create a new 3D plane, move it over here at -10, move another one at 10. We could go ahead and add the snow material to it, like so. And also do note that when we do have our bigger floor, it's going to extend much further towards the left and towards the right. Okay, so we have something that looks a little bit like this at the moment. It's one object that contains the left plane and the right plane. Now our goal is going to be to do something very similar we've done with the gameplay, but instead of using gameplay elements, we will use scenery prefabs. So I'll go ahead and I'll create another folder, called it scene element. Go down under model, and now this time, instead of taking from the gameplay folder, we will take from this scene over here, this environment. So this environment folder. And now we will choose. So we have things such as glacier or glacier. We can put them like so. And I have a feeling that these, you might not want to actually put them under the scene element unless you feel like. But at the moment, it seems like they actually look good and have the right material. So from that folder, just go ahead and pick a couple of things. You will need to just make this look somewhat good. Do note that they don't affect the gameplay whatsoever. They're only here to look good on the side, to give some different scenery in the background. Like you can have snowmen and nobody's going to notice. There it is, big snowman. And that would be, for example, one scene chunk. And of course, you would have to decorate the other side as well so it doesn't look weird. So we can do that. Maybe add a sign. Also, if it bothers you, you might want to remove the curvature for the moment. And it actually bothers me, so I'll go ahead and I'll do that. That's a tad better, at least for editing purpose. Now I'm going quite fast, but do remember that you have to make sure that these are under the right scene chunk. So sign 2, snowman, spike 3, tree, dead. They're all supposed to be under a scene chunk. It's very important that they are saved as part of the prefab. And when you move this, you move everything. What else could we do? We could do a igloo there. and add a little bit of trees. Okay, so that right here could be one scene chunk, and I'll just make sure to place it at, for example, 0. And it does, oh, wait, I forgot igloos and the trees. Let's put them right here. And let's put that back on 0. See what happens. So it does look like it matches just fine. I don't think we're going to be spawning anything right here on this side. This is going to be reserved for the initial location. But we have the scene chunk number 1. I would like you to go ahead and save it. So I grab this, save under scenery. And I might as well just remove the scene element. I forgot. And I just went ahead and I removed the scene element folder. Turns out we're just going to be dragging them from environment because we do have the right material in there. And it's just going to be a little bit easy. By the end of the tutorial, though, we might want to go and override everything. So we only use one single material like this one. But at the moment, I believe as we're working on this and as we're creating the scene chunks, it's going to save us a little bit of time. So I'm going to put that back on the proper curvature. I'll hit save. Make sure this one is saved as well. Yep. And from that point on, I can delete. Now it is time to go in our code and actually make sure we spawn another set of chunks. Now, what we could do and what I've actually done prior to recording this is I just had duplicated code, which I believe is not the best way to go around and do things. So here, for example, I had the active chunks for the scene, and I was just duplicating that over. I had 3 pieces. That's why I have a section called gameplay, because another section was called scene. But I figured out that maybe we don't want to do that. Maybe we want to keep our code cleaner instead. So here's something that I recommend you do instead. Instead of creating duplicated code instead of world generation, we'll keep them clean the way it is right now. And instead, I am going to right click, create a new C# script, call it scene chunk generation, open it in Visual Studio. And instead of doing all of that, look at this. We are simply going to remove everything. In fact, we can put that on the same line if you wish. And we are going to inherit from world generation. Like so. That's all we need to do. One line. And with that in mind, because our script works very well with chunks and the same system is being applied, we can drag and drop the scene chunk generation right here. And because we inherit, we're going to inherit from the same function. We can say, okay, this one spawns on 5. We have a chunk prefab size of 1, and this is our main camera transform. And it's going to be very important here that we drag and drop our scene chunk, but on top of that, we also need to add, and this is something I did offline, so make sure you go here on the scene chunk and you add the chunk script to it. And this one is 10 meter. If you remember, yeah, so it's 10 meter. It's not spanning over 20 meter. It's only 10 in this case. And with that in mind, let's just go ahead and press play, see what happens. We have generated this much. And oh, the floor doesn't follow, so that is on us to go fix. The floor material right here should have a curvature of 0.05. There we go. Just put it anywhere. To be honest, it doesn't matter which place you change it. And then let's hit play again. And voila, we have done it. We now have things spawning on the left-hand side and on the right-hand side. Now, obviously, the lighting isn't too good, and it's always the same scene chunk. So maybe you want to go ahead and create another one. I'll do that myself, so I'll quickly create another one so it doesn't always look like the same thing. Quite important. But that's actually where the lesson will end. Unless you want to stick around and look at me create something fairly quickly. This is the whole content for this lesson. So if you wish, make sure you go ahead and skip to the next one. Okay, and for those who don't want to skip, I'm going to quickly go ahead and create a scene chunk number 2. And do note that the more chunk you create, the better your game is going to look, the more random it's going to seem. And that's just a big plus overall. So what did we do exactly? We had left plane, right plane. We also had 2 colliders. So I'll copy that over. I'll also make sure to copy the box collider component. Go back here, paste it. We'll add a second one, paste the value as well, but switch this value over. Right. So we have these two. We could spawn a cabin, smaller one, of course, with firewood in front and a friend seal. What up? Just chilling around it. Followed by maybe a log, smaller log. This is the one we use for gameplay, so it gotta be looking different. So maybe from this angle, player won't notice. Oh, there, that's better. I'm just going ahead and I'm putting a little bit of anything, to be honest, at this point. If you're wondering what I'm doing here is I'm actually holding the V key. So by holding V, it snaps to pixels. So I can just drag this, hold V, and you see it's going to snap on every single vertices. You won't see it visually, but you'll see it on the collider, and then I can just move it using that, and it's going to snap on the other pixels on the floor. So this will work. Add a little bit more trees. They don't have to be the same size. And here we go. It's quite random. It doesn't look the best. I could be spending more time, but I just really want to see a difference in between the two chunk at the moment. So I'm going to go ahead and make sure this one has the chunk as well. So 10 in length. We can save this. I can now delete it. Go under my chunk generation. Say I have a list of 2. Drag and drop this in here. Press play, and we should be able to see 2 different type of chunks. And do we actually see it? Yeah, so the first one is the cabin, as you can tell. And then we're followed by problems, actually. It seems like it doesn't have the right distance in between them. It seems like it didn't save the fact that I've put a chunk component on it. So when it spawned, it assumed that it was 0. So that's not fairly cool. If I press play again, you can now see that it's much different. So I have proper spacing in between them. And we have 2 different types. As we move forward, we should have them spawning in different fashion and of course pooling if needed. Yep, so that is it. And we are pretty much done with the world generation. Now, the next thing we'll have to do regarding the world generation is just create more entertaining gameplay prefab and also more better looking scene chunks. But that's pretty much it.